Hey everybody, John here, and we're going to talk about rational functions. Now the good thing about rational functions is it builds heavily on the skills and knowledge that we developed during the polynomial lesson videos. And so what a rational function is actually it's one polynomial divided by another polynomial. And the numerator and denominator have to be polynomials, which means that the exponents for the terms in the numerator and denominator are going to be whole value and positive. They're going to be whole number values. So that's what a rational function is. And the ways that we talk about rational functions and what happens when we divide a polynomial by another polynomial only adds a couple of extra features over what the polynomial functions have. We're still going to have we're still going to be able to graph and find zeros by factoring, but we also have to now take into account asymptotes. And so we're going to have vertical asymptotes and we're going to have horizontal asymptotes. The horizontal asymptotes is what replaces the end behavior that we talked about with polynomials. The vertical asymptotes go hand in hand with the fact that now there are certain values that can't be in the domain of my function because perhaps, now that there's variables in the denominator, perhaps I'm going to divide by 0. And so one of those red flags is coming up because I see a variable in the denominator, and so my domain is going to be all of the numbers for which the denominator is not 0. Because if the denominator equals 0, then I'm dividing by 0. And so finding the domain, instead of it being all real numbers like it was for every polynomial, now there are certain numbers that we cannot use. Like for f of x here, I cannot plug 1 into here because 1 minus 1 is 0, and then I'd be dividing by 0. And so my domain here would be all real numbers except for 1. And here it's hard to tell what makes the denominator 0, but if I factor it, it'll be a lot easier to tell. I know x and x gives me x squared, and then what multiplies to give me 8 and adds to give me -6. So I'm going to go with -4 and -2. And so that means that if I plug 4 into here, I'm going to divide by 0, or if I plug 2, I'm going to divide by 0. And so I don't want 4 or 2 in my domain. So my domain is going to be all real numbers except for 2 and 4. Sorry, I ran out of room there. Let me rewrite that so that it looks better. Okay, so my domain is going to be all real numbers starting at -infinity going all the way to 2, but skipping over 2, and then going all the way from 2.00001 to 3.999999, but skipping over 4, starting at 4.00001 and going all the way to infinity. So that's my domain for the second one, g of x. And then for h of x, my domain is all real numbers except for 2. So that's going to be this interval right here. Now you might be looking at this thinking, but this factors x plus 2, x minus 2 in the numerator. And so can I cancel that out and then the domain is all real numbers? No. Okay, because this was originally in the equation, I cannot plug 2 into here because I would be dividing by 0. I know that at that point I would get 0 over 0, and that's actually going to result in what we call a hole in my graph. So the graph's going to look normal. Actually, this graph's actually just going to be a line, but in that line, at 2, wherever we are horizontally at 2, there will be a hole in my graph, okay? And this is the point 4, okay? So that's the domain. So the domain is no longer automatically all real numbers. We have to look at the denominator and decide. Sometimes it will still be all real numbers. If this first example had been plus here, then Oh wait, that's not true. Sorry. If this second example couldn't factor, or if this first example had been x squared plus 1, then there's no number that I can square and add 1 to it that's going to give me 0. So now vertical asymptotes, okay? Vertical asymptotes are the places on the graph where they come from the graph sort of exploding. So as I get closer to some of these points where the domain doesn't exist, like in this first example, as I get closer and closer to 1, okay, the denominator is getting really close to 0. So this is like 0.0000001 or negative 0.00001. If I'm plugging in something like 0.99999, I'm going to get this number in the denominator, and in the numerator, I'm just going to get a regular old number. So this is going to be really close to 3 minus 12, which is negative 9. So I'm going to have like negative 9 up here, divided by this really small number, is going to give me a really big number, right? Depending on how many zeros are here, that's how many zeros I'm going to get here. And so the graph blows up and gives me a vertical asymptote. So what this is saying is, as I get really close to some value from the right or the left, so what it means is, if I'm getting really close to A from either the right, that's this sign, or from the left, that's this sign, my graph is either going up to infinity or going down to negative infinity. Okay, and that would be a vertical asymptote. Now, how do we find these? Well, it's really simple. As long as the denominator is 0 and the numerator is not 0, you have a vertical asymptote. So going back to these examples, 1, x equals 1 is a vertical asymptote. X equals 4, x equals 2, those are vertical asymptotes. Here, there is no vertical asymptote because when the denominator equals 0, so does the numerator, and so there's no vertical asymptote there. I know I went over that very quickly, but we're going to do another example here. So let's find some vertical asymptotes. So we want to make sure that the numerator is not 0 and the denominator is 0. So it's easier to find where the denominator is 0 first. So in this first example, the denominator is 0 when x equals 1. When I plug x equals 1 in, does the numerator also equal 0? It does not. It always equals 1 in this case. And so x equals 1 is a vertical asymptote. And these are vertical lines, so x equals is the way to denote them. In this second example, this factors as such. And so the x-intercepts are x equals negative 3, x equals 3. These are my vertical asymptotes. The numerator is always 1, so it can't be 0. But now let's look at the last one. We have x plus 2 in the numerator, and when we factor the denominator, we get x plus 2x minus 2. So potential places where I could have vertical asymptotes are at x equals negative 2 and at x equals 2. But when I plug negative 2 into h, when I find h of 2, I get 0 over 0. This is not a vertical asymptote because this numerator is not 0. I mean, this numerator, how did I say that? The vertical asymptote, there is no vertical asymptote here because the numerator is 0, which I think I was trying to get at. This isn't a vertical asymptote because the numerator isn't 0, is I think what I was trying to say. So x equals negative 2 is not a vertical asymptote, only x equals 2 is. I hope that made sense. What's happening right here, this is actually a hole in the graph. So when two factors will cancel out like that, it's a hole in the graph, and we already talked about that. I don't think any holes come up in any of the problems that you do, so you don't have to worry too much about it. And if you do go on to take calculus, you'll talk about that more when you get there. All right. I'm going to stop here, and in the next video, I'll talk about horizontal asymptotes.